Okay, pre-cal, in this video we are going to look at more examples on finding the component form of vectors. So this one right here shows me that my initial point is R, so this is my initial point, so that means that this is going to be x1, y1, and S is my terminal point, so x2, y2. So if I'm finding the component form of W, and I can call it W or I can call it RS, either one is fine. So my component form is going to be x2 minus x1 and negative 3x or y2 minus y1. So that's going to be negative 5, and that's going to be negative 7. If you can add, you can do these. All right, so the next one, find the component form of V, and it is vector PQ, or you can call it vector V, it does not matter. This tells me that this is the initial, so that's x1, y1, x2, y2. So my component form of the x is the x2 minus x1, so negative 5 minus a negative 3. Make sure you're careful with your signs. That's why I use parentheses there. And then I've got 2 minus 4. So this becomes positive, so I've got negative 5 plus 3, so that's going to give me a negative 2, and then 2 minus 4 is also negative 2. Sorry, I guess I should have put little boxes around those. Sorry, kids. Okay, in this one, we are also going to look at the magnitude, so let me redirect your attention to the distance formula right here. That's how we find our magnitude. So that means that I have got to determine my initial and terminal point. Well, if it's vector RS, that means this is initial, R, and S is terminal. So my distance formula is what I'm going to use here. So I've got x2 minus x1 squared plus y2 minus y1 squared. Now, the way we indicate magnitude for a vector is we use a specific notation, and that indicates that we are finding the magnitude. And it would look like this. We use double bars around the name of the vector. So we defined this as vector W, so it is going to look like that. And I'm going to take x2 right there, 0 minus x1, and y2 minus y1. And this gives me negative 6 squared plus negative 7 squared, which gives me 36 plus 49. So the magnitude of vector W is the square root of 85. And you can leave it that way or find a decimal, whichever is fine with me. And then we've got example 5. It tells me to find the component form and the magnitude of the vector. And it's vector V with an initial point 4, negative 7 and a terminal point negative 1, 5. So vector V, the component form is going to be x2 minus x1, so negative 1 minus 4, and y2 minus y1, which is 5 minus a negative 7. So this is going to be negative 5. This is going to be 5 plus 7, which is 12. So this is my component form, and now I want the magnitude. So I want you to notice something. Okay, notice this. You're going to love this. All right, notice that for magnitude, oh, that's not a pretty color. Okay, for the magnitude here, see that right there? Oh, look. These values, the number that gets squared is the x component of the component form, and this value that gets squared is the y component of my component form. So if you already have the component form, you just have to take those values and square them and add them together. Woo! Life's worth living again. You're welcome, kids. Okay. Why did I write 7? Oh, you can't take me anywhere. I'm out of control. I was thinking about the last problem. Jeez Louise. Sorry, baby, it's 12. Okay, so when you add those together, and then that's a perfect square, the square root of 169 is 13. Hot diggity! Okay, now we're going to look at example 6, the resultant vector. Okay, kids, this is kind of, well, it's a little weird. It's a little hard to explain, but just think of it this way, all right? If I've got vector 1 and I've got vector 2, think of this as movement this way and movement this way to get to this end point. So these two vectors together have a resultant vector. And that resultant vector is this right here, okay? Because it starts here and it ends here, where the two vectors together start and end. So the resultant vector would be this one right here. So it's, if I'm finding the resultant vector, it's how far I travel from here to here. So if you will notice this is 1, 2, 3. So to the right 3 and up 4. So right 3 is positive 3 horizontally, and it's up, or sorry, I don't know what I'm doing, okay. And it's positive, positive 4 vertically. So the component form of this would be 3, positive 3 in the x position, movement right, and positive 4 in the y position, movement up. That is what my resultant vector would look like. Hot diggity. Also, it might help you to think of it this way. Think of the resultant vector as, let's say this airplane is flying here and the wind is pushing at it, so it kind of moves it to here. Kind of neat, huh? So this would be a resultant vector, resulting from this one being acted upon by this one. You're welcome.